Okay, today we're looking at writing and graphing inequalities and determining what the solutions are. So as we talk about inequalities, they are mathematical sentences that compare expressions. So equations were sentences that had two expressions set equal to each other. Now, instead of setting them equal, we're saying they're not equal, hence the word inequality, but we're comparing them. So we're going to use symbols such as these, so some of those should look familiar. This first symbol is your less than symbol. Sometimes you'll see the phrase is fewer than as well. And remember, one way to remember this is left and less, since they both start with L. You hold up your left hand and you make that less than symbol in front of you with your hand. That's your less than symbol. This next one is our greater than symbol, and you will sometimes see the phrase is more than as well. This symbol is our less than or equal to, so it's the less than symbol, but there's a line underneath it. That means less than or equal to. You may also see is at most or is no more than. And then is greater than or equal to, so it's that greater than symbol, but with that line underneath, so again, that means equal to as well. Sometimes you'll see is at least or no less than. Okay, so the first thing we're going to do is use those symbols to take these word sentences and write them as inequalities. So we did this with equations, but now instead of equations, we're going to have inequalities. So this first one, a number C is less than -4. So our key phrase would be is less than. So we have a number C is less than, so we want to use this less than symbol. And then that -4. C is less than -4. So again, we're comparing those two rather than setting them equal to each other. The next one, a number K plus 5, and then is greater than or equal to 8. So first of all, we have K plus 5. So I'm going to write this expression, K plus 5. Then we have the greater than or equal to symbol, and if you don't remember what it is, you just look up here in the chart we created. So greater than or equal to 8. K plus 5 is greater than or equal to 8. All right, letter C. 4 times the number Q, so 4 times the number, and then is at most. So 4 times the number Q. Remember, if we take a number multiplied by a variable, you can just set it next to the variable with nothing in between. And then is at most. We can look for that up here, is at most 16. So it looks like this. All right, so next up we have solutions. So we can write the inequalities, then we have solutions of inequalities. And this is going to be a value that makes the inequality true. So much like solutions to equations, those were just values that made the equation true. Now we have values that make the inequality true. However, I highlighted this key point here, inequality can have more than one solution. So we're going to look at that in a second. It can have more than one solution. So a solution set, that's going to be all the solutions of an inequality, because there can be more than one. So what that means, for example, if we look down here, the value of x, let's just pick a few numbers. Let's say 3, 4, and 5. Well, if I substitute those in here, 3 plus 3 is 6. Well, is this true? Is 6 less than or equal to 7? It is less than, so it is true. What about 4? If we substitute 4 in here for x, 4 plus 3 is 7. 7 is less than or equal to 7. It's not less than 7, but it is equal to, so yes, that is true. 5, if I put 5 in there, 5 plus 3 is 8. 8 less than or equal to 7. 8's not less than 7, so we would say no. But you can see just from here we have two values that make this true. So again, inequalities can have more than one solution. Let's go ahead and flip this over and look at that in some more detail. Okay, so we're going to look at these three examples and decide whether it is a solution of that inequality. So this first one, x plus 1 is greater than 7, and it's saying if x equals 8. So there's a semicolon here, and that's just separating the inequality and the solution. So what I'm going to do is substitute that 8 in there. 8 plus 1 is greater than 7. And then we're going to simplify that. 8 plus 1 is 9. And then is 9 greater than 7? Well, yes, that is true. So that means it is a solution. X equals 8 is a solution. It works. Look at the next one. If y is 4, I'm going to substitute that in here. So 7 times 4 is less than 27. 7 times 4 is 28. Is 28 less than 27 though? That's a no. So I'm just going to put an X here and say that y equals 4. That is not a solution. All right, the last one over here, z over 3 is greater than or equal to 5 if z equals 15. So I'm going to put 15 in here. 15 divided by 3 becomes 5. 5 is greater than or equal to 5. It's equal, so we would say it is a solution. Okay. All right, so now we can determine if a value is a solution of an inequality. We can also see those solutions on a graph. So when we graph an inequality, it's basically going to be a number. It's going to be a number line, and it's going to be that graph is going to show all the solutions of an inequality. So we have two ways to graph. We use an open circle when the number that the circle is on is not a solution, and then we use a closed circle when that number is a solution. So if it's not a solution, this open circle, that's going to be for your less than and your greater than, okay, because it's not going to include that number. Now, when you have this closed circle, that's going to be your less than or equal to, and your greater than or equal to, because it's going to include that number since it's equal to that as well. So let's look at some examples here. This first one, g is greater than 2. So since it's greater than, it's not equal to, just greater than, we're going to use an open circle, okay, and put it on 2. And it doesn't say equal to 2, it just says greater, so it's an open circle, meaning 2 is not a solution. 2 is not greater than 2. But we want everything that's greater than 2 included. So what I'm going to do is just draw a line that keeps going to show that everything greater than 2 is a solution of that inequality. All right, let's look at this one. M is greater than or equal to 7. Well, I didn't extend my number line far enough here. Sorry about that. So I'm just going to add 6 and 7 here. And since we're looking at greater than or equal to, I'm on the number 7, and since it says equal to, I'm going to make that a closed circle because 7 is a solution. It can be equal to that. And then I'm going to draw a line showing everything greater than that as well. So 7, 8, 27, 42, anything greater than 7 and 7. One thing you'll notice when you're graphing, that your arrow is going to go in the direction of your symbol. Okay? All right, so I want you to try this. Go down here and where it says on your own, go ahead and go through 1 through 4 and write those word sentences as inequalities. So a number n is greater than 1. Write that as an inequality. So pause the video, give that a try, and then unpause to check your work here. Okay, go ahead and check your answers. And then on 5, 6, and 7, You're going to use 3 for all of those. You're going to substitute it in there and then decide if that is a solution of the inequality. So you're going to tell me if it is a solution or is not. So pause your video again and give those 3 a try. Okay, so not a solution for number 5. 6 and 7, those would both be solutions there. All right, then go ahead and flip to the last page. And then there's 4 questions here for you to practice the graphing on your own. So you're going to determine if it's open or closed, where that circle's going, and then in what direction your arrow is. So you kind of have 3 things to focus on. So pause the video, use your example, and give those a try. And then unpause when you're ready to check your work. All right, so here are my 4 graphs. Remember to let me know if you have any questions before you get your homework started.